And welcome back. So in this video I have picked up another easy question that is called search insert position. So let's go through the problem statement. It says given a sorted array of distinct integers and a target value, return the index if the target is found. If not, then return the index where it would be if it were inserted in order. Okay, so what it says, suppose 1 3 5 6, that is your given array and your target is 5. So if you index from 0, so 0 1 2, so at 2th index there is a 5, so you are returning 5, sorry, you are returning 2, the index. In example 2 it says the target is 2, the array is same, so you can clearly see that 2 should come after 1, so the index should be 1, so 1 is being returned. So how can you do that? Okay, so the first one, you should return this index, so 0 1 2 3, so you should return 2, and in this index, this case, you have to insert 2 over here. So you are returning this is 0 and 1, so you will have to return 1. So the tentative index where this target could be. Okay, so that's all about the description part. Now let's discuss how actually you can do that. First one is very easy one, and it takes big O of n time complexity. You can easily think about it like if you start iterating from here and you increment this pointer, suppose you call it I, and you increment I until you find this target or a value which is greater than 5. So in this case, in this case you are searching for 5, so starting from 0 you cannot find a 5, so you jump over here. At 1 still no 5 is there, but at 2 you find a 5, so you are returning 2. You break out of the loop and you return 2. And in this case what happens, you start from here. At 0 you do not find a value which is greater than 2 or equals to 2, so you move over here, but here you find 3 which is greater than 2, right? So you break out of the loop and you return 1. So that was our destination. So let's see that thing in code right now. Suppose if I write that let's write the loop for int. Okay, here I need that index, so let's initialize it outside the loop and let's make it while, and there is one more thing, yeah, while say I is less than nums dot size. If you find that nums I, that is the current element, is greater than or equals to target, you break out of this loop. Okay, and outside you just return I. And obviously here you have to increment this variable. Okay, let's see if it works. It should work actually. Okay, syntax target, yeah, it runs fine using example test case. Shit, I submitted, sorry. Anyway, I think okay, it ran pretty fine, but if you follow the description, it says you must write an algorithm in big O of log n runtime complexity. So this thing runs on big O of n, so we need to write something which runs on big O of log n. So wherever you find big O of log n, then you can very fast reach to a conclusion that it it is certainly talking about binary search type of thing. Okay, so basically you do have to do a binary search, but not exactly that search. Why? Because uh, there is a probability that this element is not at all present in the array. Okay, so just little modification will do. So I will now I will tell you how to actually you can do that thing. So again, let's write down that array 1 3 5 and 6, and your target is 5 or say. Okay, so what you do is initially uh, you you divide this array into two parts. After every iteration or every function call, you have to call a recursion over here. Okay, because binary search operates in that way, recursion. You can also implement a loop, but I personally feel like recursion is much more easier to understand. So what are the steps? The first step is you have to find the middle of this array, I and j, say. Okay, so when you first call this this function, the mother function, so I is over here and j is over here. Okay, so in this case I is at 0, j is at 3. So m equals to I plus j by 2, that will be equals to 0 plus 3. Okay, so back to the track. So 0 plus 3 by 2, that gives you 1. So your first fission comes over here. So what you do right now, you get two things, two part, one this, one that. So here you have 1 and 3, and the pivot is here. Pivot means this m, this index. The second part is 5 and 6. Okay, so you compare with this value, this 3, to select any one of these segments. Either you select this or this. Okay, so you compare with 3 and see that 5 is actually greater than 3. So as the target is greater than the pivot, so you should choose the right side. Okay, so here you have now again you have to call the same function as you are using a recursion. So you have to call the same function, but this time for some other indexes. So call the same function for index m plus 1 and j. Okay, so m plus 1 means 2. Yeah, so 0 1 was 5 was of index 2 and 3. So again do the same thing, and if you follow carefully, then right in this step m becomes I plus j by 2, that is 2 plus 3 by 2, that gives you 2. Right, now you consider this element and you compare this with your target, that is 5, and you get 5 equals to 5, and then you return 2. Okay, this part is pretty simple. Why? Because you actually found this comparison, you found such an element which is actually equals to target. But if you consider this example, here you may not find you are not going to find an element which is equal to target. So you have to be just be careful enough, and you will reach to destination, no problem. So let me write it again, or I can also clear these things out a little bit. That was easier. So this is your target. So at the first step you reach over here, because 0 plus 3 by 2 gives you 1. You compare with 3. Now 2 is less than 3, so you choose this part. Okay, so let me write it over here. You have found 1 and 3 having indices 0 and 1, right? So it was 0 and this was 1, 2, 3 in this way. So again you do the same thing. 0 plus m equals to 0 plus 1 by 2, that gives you 0, right? So right now you are considering this 1. So here you can see 1 is actually less than 2, so you must consider this thing, this side. I mean, uh, from this array, from this stage, you considered m equals to 0, right? M came out to be 0, so you're getting two things. One is this side, 1 or 3. Okay, so so then you are comparing the target with 1, and you're saying that the element that you are comparing with, that is less than the target, so the target should be at the right side, so you are considering 3. So here what is this? I also equals to, sorry, here I is also equals to 1 and j is also equals to 1. Okay, so when this kind of situation occurs, this situation that I equals to j, I equals to j, then you should return this element, this I. Okay, so everything is pretty simple, just very simple. Just you have to introduce one more condition, that whenever you find I and j to be same, then you have to return that thing. Okay, you have to return I. So let's see this thing in practice right now. So okay, so I have to write another function, because here there is no provision to give arguments like I and j. Okay, so this is what I have given, this function I have given by the system. So I have to build my own function that can give arguments like I and j, that is the current to indices representing the part of the array that I am considering. Okay, so let's say here in a private scope I am writing, and you can write the same function, use the same function name. Okay, that is called function overloading. If you are familiar with, you may know. By reference int target, that also I have to give, and to other indices int I and int j. Okay, and the return type will be an integer. So here you just have to return search insert nums, then target, and then I is the leftmost index, so it is initially it is 0, and the rightmost index is nums dot size minus 1. Let's go full string and see. First of all, we need to see if I and j are same, right? If I and j are equal, then we simply return I. Okay, no, actually I don't think so, because if we have such a case where you have only one element 1 over here, and you have to insert 2. Okay, so you have to actually insert 2 here, right? So your return should be 1, not 0. But when you initialize that function I equals to j equals to 0, right? So that exception has to be there. So I think okay, let's see what happens. Okay, so first of all we need to find m, that is the middle of these two, I plus j divided by 2, and right now I have to compare with image index. So if nums m is double equals to target, just return m. In case nums m this is greater than target, just return the same function, but now you have to consider which one. Nums is greater than target, so you have to consider the left part. So I will be there and m will be there. Yes, otherwise only one condition is left, that is nums m is less than target. So in that case you have to choose the right part of the array. So return search insert nums m plus 1 and j. Okay, so what can we do here? We can put a condition, na? Yeah, we have to put a condition. Yeah, we have to put a condition. See, when suppose consider this thing here, 3 was more than 2, so 3 was greater than 2. In this type of situation we have no problem, we simply return this index. But suppose we have a condition like 1, say 1 2 3, and we have to insert 4. Okay, so if you follow along the same step, you will see that at last you will find 3. Okay, where I will be equals to j equals to 2, right? 0 1 2. But you should not return 2. Why? Because 4 should be inserted over here, not here. So you should return 2. Yeah, so in that kind of situation, and here also in case the target is greater than the current element which we are comparing with, so in that case we should return I plus 1, not I plus 1 should be returned. That is why we need to put another condition here. Let's use a tertiary expression. If in case nums I is greater than this target, then I will be returned, otherwise I plus 1 will be returned. Okay, now let's run the code and see if it works or not. I and m. Okay, sorry, we have missed the target. Again here we have missed the target. Yeah, it runs fine. So let's give our custom test cases to see if it performs well. So our first test case is giving us 7 to see whether it can find this index over here or not, and the second one is a single element where I have to insert, say, 3. Okay, and the same thing 1, and now we want to insert 0, and here is a constraint that the length should be more than or equals to 1. So we have not have this edge case like an empty array is given and we have to insert 2. No, that thing is not required. Okay, so let's run this code and see whether our custom test cases pass or not. Yeah, it runs well. So let's see if we can submit successfully. Okay, it gives a wrong answer. Why? Okay, so here we have to put equals to also, because if we have have one one over here and we want to insert one, so we have to put this now. So here we have, earlier we had only greater than condition, so in any other cases it was returning I plus 1. So in case that uh, target is equal to that current that element under consideration, in that case also it was not returning that position, that index. So that was a problem. So that thing is good. And let's see if that test is whether it passes or not. Yeah, so it does a good job. So let's submit now. Yeah, it runs pretty fine. So thank you. uh, and in next video I will go over some really interesting stuff, like buying and selling stocks and that kind of problem. So yeah, take care, bye.